Good morning, everybody. Today we are going to be doing some practice with 4C, which is the properties of algorithms. So on this page are our practice problems that we're going to do. So you can either just do them on your own piece of paper, or you can use the attached practice page. You can print that out if you want. Either way, take a few minutes and try all these problems. The first set, these first four here, you are using the change of base formula and a calculator to evaluate the logarithm. So look that change of base formula up in your notes if you need to. Then these next set of problems, 5 through 10, says express as a single logarithm. So that means condense using the properties. And then these last ones here, write as a sum or difference of logarithms. That means we're trying to expand. So take a few minutes and try those problems. Go ahead and pause the video here. When you are done, come back to the video and check your work. Okay, hopefully you have checked or tried all the problems. So now go ahead and take a few minutes and check your work. Once you've checked your work, if you don't have any questions that you need to go over, then you are done and you can answer the question on the Google form. If there are any of these questions that you're not sure how to do, keep watching the video so that you can see where we are getting these answers from. All right, so the first set of problems is the change of base formula. So obviously we need to know the change of base, and we're going to need a calculator here. So if you look at these bases, we've got a base of 9, 3, square root of 3, and 7.9. Our calculator, if we look at the log and natural log buttons on our calculator, they are only the base 10 and the base e. That's why we need a different way to find these logarithms. So the change of base formula says this. If we have log base b of a, we can change it to any base. We're going to change it to base 10 though. So this would be log base c of a. The a is what we're taking the logarithm of, divided by log base c of b. The b is the base. The c is any number that we want, but we're going to change it to base 10 because that is what we can do on our calculator. All right, so let's look at our problems here. Number one is log base 9. This is the b of 79.48. That's the a. So to evaluate this, I'm going to change it to log base 10. I don't have to write the 10 since this is the common log. So I'm going to enter it in my calculator like this. Log of 79.48 divided by log of 9. So again, we do need a calculator. Otherwise, we wouldn't be able to evaluate this. So you do need some kind of calculator that does logarithms or Desmos. So whatever calculator you have, we got to enter that in. So log of 79.48 divided by log of 9. Oops, I entered that in wrong. 9 log equals. And this says round your answer to 3 decimal places. So that's why I rounded to 3 decimal places. This would be approximately 1.991. Okay, next one is in the form log base b of a. So to evaluate that, I have to do log of a, so log of 195, divided by log of b, which is log of 3. Again, enter that on our calculator. 195 log divided by 3 log equals, now this I get 4.799. If I rounded that to 3 decimal places, the next number after the third place, after the 9, is 6. So it would round up, So this is actually going to round to 4.800. That's the same as 4.8, but since it says 3 decimal places, I want to put zeros in for the second and third decimal places. All right, number 3. This is log base b of a. So when I enter it in my calculator, I have to do log of 146.3 divided by a log of square root of 3. And let's divide that on our calculator. You got to figure out how to do a square root on your calculator. Mine, I have to hit this second button, and then the square root comes up right here. I'm also, to put it in correctly, we'll have to put parentheses when I'm doing that square root of 3. So you'll have to figure out how to plug this in your calculator. So 146.3 log divided by, in parentheses, 3 square root log. Okay, so now you can see how it looks on my calculator. Log of 146.3 divided by log of square root of 3 equals approximately 9.076. And last one, this is log base b of a. So to evaluate that on our calculator, I'm going to do log of a, log of 7.5, divided by log of b, which is log of 7.9. And approximate on our calculator. Excuse me. Log of 7.5 divided by log, oops, I entered that in wrong, 7.9 log equals approximately 0.975 if I round it to 3 decimal places. All right, so that is using the change of base formula, which we have to use anytime there's a base that's not a 10 or an E, like all of these. All right, so now let's move on to the expanding and condensing problems. So on this one, we're asked to express as a single logarithm. So that is telling us to condense. So we do need to know our 3 properties of logarithms that we've been using. So our first one, if we have log base b of m plus log base b of n. So if we have 2 separate logarithms with a plus sign in between, we can rewrite it as log base b of m times n. The second property is the same, but with subtraction. Log base b of m minus log base b of n can be rewritten as log base b of m divided by n. So this is, we'll call this one property 1, this one property 2. And then the third property is dealing with powers. So if we have a constant in the front, c times log base b of m, we can move that constant to the exponent log base b of m to the c power. Okay, so I labeled these 1, 2, and 3 so you can know which one I'm referring to as I am explaining. All right, so we're trying to condense these. Number 5, we have log base c of x plus log base c of y. There's a plus sign in between, so this is in the form log base c of m. The x is like the m plus log base c of n. The y is like the n. So I can combine those. This is using property 1 into one logarithm. It's going to be log base c of m times n. So it's going to be x times y. To write x times y, we just write it like this, xy. And that's it. This was only using one of the properties there. All right, number 2. This, I see it has the subtraction sign in between, but before I can do anything with the subtraction, I have to do something with this constant in the front. So first, this 2 in the front, it's only in front of this one, the log base b of x. So when I use property 3 here, I'm only putting it to the exponent of the x. So then I could rewrite this as log base b of x squared minus log base b of y. Notice here it's not written with parentheses around the x and the y. I usually write it with parentheses just out of habit. All right, now we can see that this looks like the second property here because there's a minus sign. So this is the m and this is the n. So when I combine it, I can rewrite this. It's still going to be log base b, the base doesn't change, of m divided by n. So it's going to be x squared divided by y. And now it's condensed into one logarithm. All right, number 3, both of these have numbers in front. The 3 is in front of the log base 6 of x. I know it's only log base 6 of x because the x is, the plus 5 here is not in parentheses with the x. So this 3 can go to the exponent of the x, and this 5 can go to the exponent of the x minus 6. So that's the first step. So I'm going to have log base 6 of x cubed plus log base 6 of x minus 6 to the 5th power. You can have double parentheses here if you want. So now this has a plus sign in between, and this is in the form log base b of m plus log base b of n. So when I rewrite this, it's going to be m times n. So log base b of m times n, I would write that as x cubed times x minus 6 to the 5th. Since they're multiplied, I just put them next to each other like that. And now it's condensed into one logarithm. All right, let's look at number 8. So this one has a minus sign in between. Before I can combine those into one logarithm, I have to deal with the number, the constant that's multiplied in front of each one of these. So this expression, natural log of x minus 7, has an 11 in front of it. So I'm going to move that to the exponent. And then this one, natural log of x, has a 2 in front of it. So I'm going to move that to the exponent. So then we would have natural log of x minus 7 to the 11th power minus natural log of x to the 2nd power. Now I can combine these into one logarithm. This has a minus in between. So this is in the form log base b of m. So this whole expression is m minus log base b of n. So this expression is n. So when I condense it into one logarithm, it's going to be natural log of m divided by n. So these will be divided. So I'm going to have x minus 7 to the 11th power divided by x squared. So I have natural log of this whole expression, natural log of x minus 7 to the 11th over x squared. And that's how we would write the answer on that one. All right, number 9. This one's a little different because it has these parentheses here. So anytime we have parentheses, so notice I have parentheses around this whole expression. I'm going to do order of operations. So I'm going to condense these first before I do anything with the half. So here, these have a minus in between. So this is in the form log base b of m minus log base b of n. Oops, this is the m and this is the n. So when I put those together into one expression, it's still going to be log base 6. And since this is a minus in between, it's going to be m divided by n. So I'm going to have x minus 9 over x. And I still have the half in front here. So it's in front of this whole expression. So now I have to deal with the half. So this half has is a constant that's multiplied in the front. So now this half can move to the exponent. So now it'll look like this: log base 6 of x minus 9 over x to the half power. Now, one other thing, doesn't use any of the properties, but it does use our knowledge of exponents. So remember, when we have a fractional exponent like this, it can be rewritten as a radical. This would end up being a square root. A 1/2 power is a square root. And so since the x minus 9 over x is to the half power, I could write that under a square root. So log base 6 of square root of x minus 9 over x. And that's how I would write this expression. All right, and number 10. Notice this one has 3 logarithms. So when we're done, we're going to end up with only 1 logarithm. So first of all, before I can condense these, they all have a constant in the front. So all of these constants are going to move to the power. So this will be log base 4 of 2 to the 5th power, plus this will be log base 4, log base 4 of x minus 8 to the 1/5 power, and then minus log base 4 of x to the half power. Now, again, before I condense these, oh my gosh, that's my son playing with the chair, pushing it around. All right, before I condense these, I am going to deal with these fractional exponents. No. So this 5th power can be written as a 5th root, and the half power can be written as a square root. So, and then right here, since it's a number, 2 to the 5th power, if you want, you can write it as 32, or you can leave it as 2 to the 5th power. I'm going to write it as 32. So this I'm going to rewrite as log base 4 of 32. This one I'm going to rewrite as log base 4 of the 5th root of x minus 8. And then this one I'm going to write as log base 4 of the square root of x. Okay, now I need to condense these. We can just go in order. I can condense, since there's 3 of them, I'm just going to go left to right, add and subtract from left to right. So I'm going to condense these first. Since these are added, this is in the form log base b of m plus log base b of n. And so when I put them together, it's going to be log base b of m times n. So log base 4, I'm just going to write that as 32 times the 5th root of x minus 8. Since it's multiplied, they're just next to each other like that. And then I still have the minus log base 4 of square root of x. Now I can put these two together. Now there's a minus in between, and this is in the form log base b of m minus log base b of n. So when I put these together, they're going to be divided. It's going to be in the form log base 4 of m divided by n. So on the top, I'm going to have 32 times 5th root of x minus 8. On the bottom, I'm going to have square root of x. And that's what my final answer would look like on that one. Now, all 3 of those logarithms are condensed into one logarithm. Now, our last problems here are, it says write as a sum or difference of logarithms, express powers as factors. So what this is telling us to do, since we're trying to write it as a sum or difference of logarithms, so logarithms that are added or subtracted, even though it doesn't come out and say it, we're trying to expand in this case. So we're using the same 3 properties. This one, number 11, is in the form right now, log base 5 of m divided by n. So the 7 is the m and the 2 is the n. So when I rewrite it, I can rewrite this into 2 logarithms. It's going to stay log base 5, but it's going to be log base b of m minus log base b of n. So my first one will be log base 5 of 7, that's the m, minus log base 5 of 2, which is the n. And that's our expanded expression there. All right, if we look at 12, this actually has 3 different terms, the 4, the square root of r, and the s. So when I'm done, I should have 3 separate logarithms. But for now, I'm just going to do one part at a time. So here we have log base b. This is in the form m divided by n. So this expression is the m, and this one is the n. So when I rewrite it, it's going to be log base 17 of m. So right now, that's 4 square root of r minus log base 17 of s. So log base b of m minus log base b of n. Okay, now this still needs to separate more because right now it's r times, or 4 times square root of r. So this is in the form log base b of m times n. So the m is 4 and the n is square root of r. So when I separate that part separates to 2 logarithms with a plus sign in between. So log base 17 of 4 plus log base 17 of square root of r. Now, I still have this minus log base 17 of s. Okay, even though I am done expanding this into 3 logarithms, I'm not completely done with the problem because I have to deal with this radical here. So we always, in this case, we're going to rewrite a radical as an exponent. So I'm going to rewrite this as r to the half power. Remember, a square root can be written as a half power. Now, since the half is in the power, I could take that half and move it to the front of the logarithm. So here's what my final answer is going to look like. Log base 17 of 4 plus 1/2 log base 17 of r minus log base 17 of s. So this is our expanded answer. And you know it's expanded all the way when each number or term we're taking a logarithm is just by itself. There shouldn't be any powers or multiples. So this is just 4, r, and s. All right, we got a couple more to go. Number 13 also is in the form log base b of m divided by n. So when I rewrite this, it's going to be 2 logarithms with a minus in between. So I'm going to have log base 4 of x to the 4th minus log base 4 of y to the 8th. Now, I'm not done yet because I still have powers. So now both of these have a power. So this 4 can move to the front of this expression, and this 8 can move to the front of this expression. So now when I rewrite it, I'm going to have 4 log base 4 of x minus 8 log base 4 of y. Now x and y are by themselves, and this is my expanded expression. All right, we got a couple more. The next one, number 14, is also in the form log base 3 or log base b of m divided by n. So when I rewrite it, there's going to be two logarithms with a minus sign. So this is going to be in the form log base 3 of m. So that's x plus 5. That's one whole expression because they're added, not multiplied. And then minus log base 3 of x cubed. So again, x plus 5, there's no property for separating that because it's not m times n. They're two numbers that are added. So this is actually just going to stay like it is. Where this one, though, x to the third power, I have to rewrite this power. So this power can move to the front of that expression. So after I rewrite it, I have log base 3 of x plus 5 minus, I've got the 3 in front, so 3 log base 3 of x. And now it is expanded because each term we're taking the parentheses of, or the logarithm of, is as simplified as possible. All right, the last one here is a little bit more complex because you notice we have a cube root, so we're going to have to deal with that first. And then we have an x to the 5th, y to the 8th, and z squared. So we have 3 terms. So when we're done, we should have 3 separate logarithms. First of all, we have to deal with the cube root. All of this is under the cube root. So first I would have to rewrite that before I even use any of the properties. So I'm not using any of the properties yet. I'm just rewriting the cube root. I'm going to rewrite that as a 1/3 power. So I'm going to have log base b of x to the 5th, y to the 8th over z squared. And that's all going to be to the 1/3 power. The reason I need to rewrite that is because I can't separate any of this when it's all under the cube root. So I have to deal with this cube root. By changing it to a 1/3 power, now I can move that 1/3 to the front of this expression. So now I would have 1/3 log base b of x to the 5th, y to the 8th over z squared. So I moved the 1/3 to the front. Now I can expand this. To start out with, it's in the form m divided by n. And this whole expression is the m, this whole thing here. And then this is the n. So when I rewrite that, it's going to be in the form log base b of m minus log base b of n. So just that part is going to be log base b of x to the 5th, y to the 8th, minus log base b of z squared. Okay, so notice it's in the form log base b of m minus log base b of n. But this whole thing, this whole expression had the 3rd in front. So I have to put this in parentheses with the 3rd in front still. Okay, I'm not done yet though, because this still needs to be expanded more. This expression here is in the form log base b of m times n. So the m is x to the 5th and the n is y to the 8th. So when I expand that, it's going to be in the form log base b of m, so log base b of x to the 5th, plus log base b of n. There are going to be two logarithms with a plus in between. So log base b of y to the 8th. Okay, so that's what this part gets rewritten. And then I still have the minus log base b of z squared. And I still have the 1/3 in front of all of this. Okay, I'm still not quite done yet. Hey, you're okay. You're okay. He's mad because he can't get into the cabinets. So each of these have an exponent. So I have to deal with all of those. So the 5 goes in front of this expression, the 8 goes in front of this expression, and the 2 goes in front of that expression. So now I have the 1/3 in front, and then here I have 5 log base b of x plus 8 log base b of y minus 2 log base b of z. And that whole thing is in parentheses, and I have a 1/3 in front of the whole expression. So you can write it like this, or if you didn't want to write the 1/3 in front with parentheses, you can also distribute the 1/3 to each of these. So here's another way you could write this one. 5/3 log base b of x. So that's just 1/3 times 5 plus 8/3 log base b of y. That's just 1/3 times 8 minus 2/3 log base b of z. That's 1/3 times 2. So I'm just distributing the 1/3. So both of these are correct, and it doesn't matter which way you write them. That's more of a personal preference thing. Oh, he got in the cabinet. So good thing we are done. All right, everybody. See ya tomorrow.